There was a time when car companies didn't sell subscriptions. They sold engineering miracles. Honda put supercar technology into an $18,000 car. Mazda sold a 9,000 RPM rotary, cheaper than a Camry. No fake engine sounds, no software locks, just brilliant engineers solving impossible problems. Today, we're counting down 12 cheap cars that were real engineering masterpieces. And number 1 changed the entire industry. Number 12, Ford Focus, 2000 to 2007. The first generation Ford Focus sold for $13,000 to $18,000 new and brought European chassis engineering to American economy buyers suffering through penalty box escorts. Under the hood sat a 2.0-liter VTEC inline 4, making 110 to 130 horsepower, unremarkable power hiding, revolutionary chassis engineering underneath. Ford of Europe's engineers created fully independent suspension front and rear using sophisticated control blade, multi-link geometry, typically reserved for luxury sedans costing 3 times as much. The control blade rear suspension represented genuine innovation in affordable cars. Rather than cheap torsion beam axles that competitors used, Ford invested in independent rear suspension, delivering handling that embarrassed BMWs. The body structure used hydroform frame rails, creating rigidity, improving both handling and crash safety. Interior packaging was brilliant. Despite compact dimensions, interior space rivaled mid-size sedans through intelligent design. Consumer Reports consistently ranked the Focus as one of the most reliable economy cars, with the VTEC engine routinely crossing 200,000 plus miles with basic maintenance. The steering feel, body control, and cornering capability made journalists question why anyone would buy premium brands when the Focus drove this well. Clean examples now sell for $3,000 to $7,000. Absurd value for this engineering excellence. But does Ford's European brilliance match what Mazda accomplished with rotary engine magic? Number 11 answers that. Number 11, Mazda RX-8, 2004 to 2011. The Mazda RX-8 sold for $26,000 to $35,000 new and housed the only rotary engine in production, one of automotive engineering's most ambitious masterpieces. Under the hood sat Mazda's 1.3-liter, 13 BMSP Renesis rotary, making 232 to 238 horsepower, triangular rotors spinning in epitrochoid housings rather than pistons reciprocating in cylinders. This represented engineering stubbornness. Mazda perfected rotary technology while every other manufacturer abandoned it as impossible. The Renesis engine achieved what seemed impossible: rotary power with emissions compliance without turbochargers. Mazda's engineers relocated exhaust ports from periphery to side housing, eliminating port overlap, causing incomplete combustion. The result? An engine redlining at 9,000 RPM with smoothness that piston engines fundamentally cannot achieve. Rotary motion eliminates reciprocating mass and vibration. Power delivery felt like an electric motor, perfectly linear from idle to redline. The controversy: rotary engines consume oil by design, approximately 1 quart per 1,000 miles, because Mazda injects oil into combustion for apex seal lubrication. Properly maintained RX-8s with 3,000-mile oil changes achieved 100,000 to 150,000 miles before apex seal replacement. The chassis featured perfect 50-50 weight distribution, rear-wheel drive, and suicide doors providing access without B-pillars. Clean examples sell for $8,000 to $18,000, the last rotary before Mazda abandons the technology. But does rotary obsession match Honda's first hybrid? Number 10 answers that. Number 10, Honda Insight, 2000 to 2006. The first generation Honda Insight sold for $18,000 to $21,000 new and represented automotive history's most ambitious project, the first mass-produced hybrid vehicle sold in America, beating Toyota Prius by 7 months. Under the hood sat Honda's 1.0-liter 3-cylinder, making 67 horsepower, paired with a 13-horsepower electric motor. Modest power hiding, revolutionary integrated motor assist technology, seamlessly blending electric and gasoline power. The engineering brilliance extended beyond the hybrid system. Honda constructed the Insight using an aluminum space frame, technology borrowed from the $90,000 NSX supercar, creating a vehicle weighing just 1,850 pounds despite hybrid components. The aluminum monocoque achieved strength-to-weight ratios impossible at this price, with construction techniques typically reserved for vehicles costing 10 times as much. The aerodynamic body achieved a 0.25 drag coefficient, one of the lowest ever, through extensive wind tunnel testing and rear-wheel skirts serving genuine aerodynamic purpose. The result? Real-world fuel economy exceeding 60 miles per gallon, combined with highway figures reaching 70-plus miles per gallon. Numbers embarrassing modern hybrids 2 decades newer. The 5-speed manual transmission connected drivers to the powertrain. Consumer reports noted the hybrid system proved remarkably reliable, with examples routinely crossing 200,000-plus miles on original batteries. Clean examples sell for $5,000 to $12,000. Brilliant value for automotive history's first practical hybrid. But does Honda's hybrid innovation match Nissan's V6 perfection? Number 9 answers that. Number 9, Nissan 350Z, 2003 to 2008. The Nissan 350Z sold for $26,000 to $33,000 new and brought legitimate sports car performance to pricing, making Porsche Boxsters look like ripoffs. Under the hood sat Nissan's legendary 3.5-liter VQ35D EV6, making 287 to 306 horsepower, an all-aluminum dual overhead cam engine that Ward's Auto named to its 10 best engines list for 14 consecutive years. This represented genuine engineering excellence through perfect intake runner tuning, aggressive cam profiles, and internal balance, creating smoothness from idle to 7,000 RPM redline. Nissan's engineers achieved naturally aspirated V6 power rivaling turbocharged engines while maintaining bulletproof reliability. The VQ35DE featured lightweight aluminum construction, individual ignition coils, and variable valve timing on intake and exhaust. The result? Linear power delivery with a distinctive intake howl. The 6-speed manual featured precise shifter action, while 2009 plus models received synchro rev match, automatically blipping throttle during downshifts. Supercar technology in affordable sports cars. The chassis engineering was equally impressive. Front midship engine placement positioned the V6 behind the front axle, achieving near-perfect 53-47 weight distribution. Independent suspension used forged aluminum components, and body structure achieved rigidity, creating telepathic handling. Consumer reports noted the VQ35DE routinely crossed 200,000-plus miles with routine maintenance. Clean 350Zs command $12,000 to $25,000, rising because these are the last affordable, naturally aspirated sports cars. But does Nissan's V6 mastery match Subaru's rally-derived AWD brilliance? Number 8 answers that. Number 8, Subaru WRX 2002 to 2007. The first-generation WRX sold in America for $24,000 to $26,000 new and brought World Rally Championship technology to suburban driveways at impossible pricing. Under the hood sat Subaru's legendary 2.0-liter EJ205 turbocharged flat 4, making 227 horsepower, a boxer engine using horizontally opposed pistons, creating inherently balanced power and low center of gravity, fundamentally changing handling. This wasn't badge engineering. The WRX shared genuine DNA with Subaru's rally cars dominating WRC. Subaru's engineering brilliance was symmetrical all-wheel drive, mechanical center, differential distributing power 50-50 front to rear, continuously rather than reactive systems waiting for slip. This created traction where power transferred seamlessly between wheels, making launches effortless and cornering supernatural. The boxer engine's horizontally opposed configuration positioned cylinders flat rather than upright, lowering center of gravity by several inches compared to conventional engines, a fundamental advantage creating handling balance competitors achieved only through expensive suspension modification. The 5-speed manual featured short throws with gear ratios optimized for turbocharged delivery. The TD04 turbocharger spooled aggressively, delivering immediate boost. Subaru understood rally performance required more than power. It required chassis rigidity, suspension geometry, and AWD calibration working seamlessly. Consumer reports noted transmission issues on some examples, but the EJ205 routinely crossed 200,000-plus miles with 3,000-mile oil changes. Clean WRXs command $15,000 to $28,000, double original pricing, as the last analog WRX before electronics ruined the formula. But does rally technology match Mini's supercharged brilliance? Number 7 answers that. Number 7, Mini Cooper S, 2002 to 2006. The first-generation Mini Cooper S sold for $19,000 to $23,000 new and represented BMW engineering applied to a compact package that seemed impossible. Under the hood sat a 1.6-liter supercharged inline-4, making 163 horsepower. Modest numbers hiding brilliance where BMW chose supercharging over turbocharging specifically for throttle response. The Eaton M45 Roots-type supercharger delivered boost instantly from idle with zero lag, creating naturally aspirated feel with forced induction performance. BMW's engineers faced a challenge: make the Mini fun while maintaining compact packaging and acceptable fuel economy. The solution was brilliant: front-wheel drive with McPherson struts and multi-link rear suspension, delivering handling precision, embarrassing rear-wheel drive sports cars. The steering was electrically assisted but calibrated for maximum feedback. BMW understood electric steering didn't have to feel numb with proper tuning. The 6-speed manual featured close ratios and short throws with mechanical precision. Chassis rigidity came from BMW engineering. Strategically placed reinforcements created a structure feeling solid while maintaining nimble handling. The supercharger whine became addictive, audible reminder you were driving something special. Real-world fuel economy approached 30 miles per gallon combined despite spirited performance, proving efficiency and fun weren't mutually exclusive. Consumer reports noted the supercharged engine achieved reliable 150,000-plus mile service when maintained properly. Clean Cooper S examples sell for $6,000 to $12,000. Brilliant value for this driving engagement. But does Mini's brilliance match Acura's naturally aspirated 4-cylinder masterpiece? Number 6 answers that. Number 6, Acura RSX Type-S, 2002 to 2006. The Acura RSX Type-S sold for $23,000 to $24,000 new and housed one of the most brilliant naturally aspirated 4-cylinders ever created. Under the hood sat Honda's legendary 2.0-liter K28 inline-4, making 200 horsepower, achieving 100 horsepower per liter without forced induction through VTEC technology, representing peak Honda engineering. The engine redlined at 8,000 RPM, delivering power building linearly with VTEC crossover at 5,800 RPM, transforming character from efficient commuter to screaming race motor instantly. Honda's engineers created an engine so precisely balanced it could sustain 8,000 RPM operation continuously without damage. Internal components weighted and balanced to tolerances typically reserved for race engines. The VTEC system combined Honda's VTEC variable valve lift with continuous cam phasing, creating an engine delivering efficiency at low RPM and explosive power at high RPM. The 6-speed manual, Honda's close ratio synchromesh unit, featured precision shifter action with gear ratios optimized, keeping the engine in its power band. Chassis engineering matched engine brilliance. McPherson struts and sophisticated multi-link rear suspension delivered telepathic handling. The body structure used high-strength steel, strategically creating rigidity, making the RSX feel substantial despite compact dimensions. Interior ergonomics were typical Honda excellence. Consumer reports consistently ranked the RSX as one of the most reliable performance cars, with the K28 routinely crossing 200,000-plus miles with routine maintenance. Clean Type-S examples command $12,000 to $22,000, nearly original MSRP, as peak Honda before turbochargers replaced naturally aspirated perfection. But does Honda's VTEC's mastery match VW's impossible W8? Number 5 answers that. Number 5, Volkswagen Passat W8, 2002 to 2004. The Volkswagen Passat W8 sold for $38,000 to $42,000 new and represented one of the most audacious engineering projects in history, stuffing an ultra-compact 4.0-liter W8, making 270 horsepower into a family sedan. The W8 configuration, essentially 2 narrow-angle VR4 engines mated at 72-degree angle, represented engineering ambition bordering on insanity. This wasn't badge engineering. VW's engineers created a genuinely unique configuration that had never been mass-produced at this displacement. Volkswagen's engineers faced a problem. They wanted V8 smoothness and power in a package fitting transversely for all-wheel drive. The W8 solution was brilliant. 8 cylinders in incredibly compact configuration allowed the engine to fit where conventional V8s couldn't. The result? An engine revving smoothly to 6,000 RPM with distinctive howl sounding like nothing else. Not quite V8 muscle, not quite V6 refinement, something entirely unique. The engine featured dual overhead cams, variable valve timing, and engineering complexity that made mechanics weep. The 4-motion all-wheel drive delivered traction seamlessly, and suspension tuning created balance between comfort and handling. Here's the controversy. The W8 was made maintenance-intensive and temperamental. Timing chain issues, cooling failures, and electrical gremlins plagued examples, with repairs costing amounts exceeding the car's value. But as pure engineering ambition, the W8 represented Volkswagen at its most audacious. Clean W8s sell for $5,000 to $10,000. Absurd depreciation. The W8 proved masterpieces don't require commercial success. But does VW's audacity match GM's roadster brilliance? Number 4 answers that. Number 4, Pontiac Solstice, Saturn Sky, 2006 to 2009. The Pontiac Solstice and Saturn Sky sold for $20,000 to $28,000 new and represented GM's most successful attempt at creating an affordable roadster since the original Miata. Built on GM's Kappa platform, rear-wheel drive architecture created specifically for these roadsters, the engineering brilliance was achieving sports car dynamics at pricing undercutting Mazda. Under the hood sat various engines, but the masterpiece was the 2.0-liter turbocharged Ecotec, making 260 horsepower in GXP/Redline variants, power-embarrassing cars costing substantially more. GM's engineers created the Kappa platform from scratch rather than adapting existing front-wheel drive architecture, a decision adding development costs but delivering genuine rear-wheel drive dynamics. The platform featured hydroformed steel frame, creating structural rigidity, making the Solstice/Sky feel expensive. Suspension used sophisticated multi-link geometry front and rear, with tuning delivering handling balance between playful and confidence-inspiring. The result? A roadster feeling genuinely special rather than compromised economy car with roof cutoff. The 5-speed manual and base models featured adequate gearing, but GXP/Redline variants received close ratio 6-speed delivering precise shifts and ratios optimized for turbocharged power. The turbocharged Ecotec delivered explosive acceleration, 0 to 60 miles per hour in 5.5 seconds, rivaling Porsche Boxsters costing twice as much. The engineering compromise was interior space. The Kappa platform prioritized driving dynamics over practicality. Consumer Reports noted the turbocharged Ecotec achieved reliable 150,000-plus mile service. Clean examples sell for $8,000 to $18,000. Brilliant value. But does GM's brilliance match Mazda's chassis engineering masterpiece? Number 3 answers that. Number 3, Mazda 3, 2004 to 2009. The first generation Mazda 3 sold for $14,000 to $22,000 new and represented Mazda's Zoom philosophy at its purest, an affordable compact engineered to deliver driving engagement luxury manufacturers claimed required premium pricing. Under the hood sat various engines, but the masterpiece was the 2.3-liter MZR inline-4, making 160 horsepower. All aluminum construction with dual overhead cams and variable valve timing, creating power delivery feeling eager and responsive rather than merely adequate. The chassis engineering made the Mazda 3 legendary. Fully independent suspension front and rear using sophisticated multi-link geometry typically reserved for luxury sedans. While competitors saved costs with cheap torsion beam rear axles, Mazda invested in proper multi-link rear suspension, delivering handling embarrassing cars costing substantially more. Steering calibration was brilliant. Electric power assist tuned for maximum feedback and precision rather than isolation, creating steering, communicating road surface texture, and tire grip clearly. The body structure used extensive high-strength steel, creating rigidity, making the Mazda 3 feel substantial over rough roads while maintaining nimble handling. Mazda's engineers understood driving engagement comes from the whole package. Responsive engine, precise steering, controlled body motions, and chassis feedback connecting driver to road. The 5-speed manual featured short-throw precision, making every shift mechanical and deliberate. Consumer Reports consistently gave the Mazda 3 top reliability ratings, with engines routinely crossing 200,000-plus miles. Clean examples sell for $5,000 to $10,000. Absurd value for this experience. But does Mazda's brilliance match Honda's naturally aspirated perfection, achieving the impossible? Number 2 answers that. Number 2, Honda S2000, 2000 to 2009. The Honda S2000 sold for $32,000 to $35,000 new and housed one of the most brilliant naturally aspirated engines ever created, representing Honda engineering at its most obsessive and uncompromising. Under the hood sat the legendary 2.2-liter EF22 C1 inline-4, making 237 horsepower, Honda achieving 100 308 horsepower per liter without forced induction through F1-derived VTEC technology and engineering obsession prioritizing high-rev character. The engine redlined at 8,000 RPM, delivering power building linearly with smoothness, feeling more electric motor than internal combustion. Honda's engineers created an engine so precisely balanced it could idle with a coin standing on edge without falling. Internal components weighted and balanced to tolerances reserved for race engines. Titanium connecting rods reduced reciprocating mass, allowing higher RPM. Forged pistons provided strength for sustained high RPM use. And individual throttle bodies delivered instantaneous response. The VTEC crossover at 6,000 RPM transformed engine character from efficient to explosive. Cam profiles switching through hydraulic actuators, creating two distinct deliveries in one engine. Chassis engineering was equally brilliant. Perfect 50-50 weight distribution achieved by mounting the engine behind the front axle. X-bone frame structure, creating rigidity, making the S2000 feel telepathic, and double wishbone suspension at all four corners, delivering handling precision, embarrassing expensive cars. The 6-speed manual featured precise Honda engineering with short throws and mechanical feedback. Consumer Reports noted the F22C1 routinely achieved 200,000 plus miles with routine maintenance. Clean S2000 sell for $25,000 to $45,000, more than original MSRP, as the last naturally aspirated Honda Roadster. But does Honda's perfection match what one affordable sedan accomplished, changing an entire segment? Number 1 answers that. Number 1, Honda Accord Fi 6-speed manual, 2003 to 2007. The absolute engineering masterpiece that costs just $24,000 new is the 7th generation Honda Accord Fi 6 with 6-speed manual, a family sedan delivering more genuine engineering excellence per dollar than vehicles costing 5 times as much. Under the hood sat Honda's legendary 3.0-liter J30A4 V6, making 240 horsepower, a VTEC-equipped engine delivering smooth, linear power from idle to 6,800 RPM redline, with refinement embarrassing luxury sedans while maintaining bulletproof Honda reliability that routinely achieved 300,000 plus miles with only routine maintenance. The engineering brilliance started with the engine. All aluminum construction saved weight, dual overhead cams with VTEC on both banks created broad power delivery, and internal balance was so perfect the engine felt silky smooth at any RPM. The V6 featured individual ignition coils eliminating distributor complexity, variable valve timing optimizing power and efficiency, and engineering routinely achieving 300,000 plus miles. Ward's Auto named the J-Series Vive 6 to 10 best engines multiple times, recognizing excellence competitors couldn't match at this price. Honda's engineers gave the Accord double wishbone front suspension, expensive multi-link geometry that Honda maintained when every competitor switched to cheaper McPherson struts to save costs. This created steering feel and handling precision, making the Accord drive like a sports sedan. The 6-speed manual, offered exclusively on V6 coupes, represented the masterpiece's peak. Close ratio gearing, short throw shifter with mechanical precision, and engagement making every shift deliberate and connected. Consumer Reports consistently ranked the 7th-gen Accord as one of the most reliable vehicles ever tested. Clean examples sell for $8,000 to $15,000. Absurd pricing for engineering excellence that changed expectations forever. And there you have it, 12 cheap cars that were actually engineering masterpieces, proving brilliance doesn't require premium badges. From Honda's VTEC perfection to Mazda's rotary obsession, these vehicles represent genuine innovation that changed the industry. Thanks for sticking with us. You're the enthusiast who recognizes real engineering doesn't need marketing to be brilliant. Check out our video on cars that change the automotive industry forever. Hit subscribe because we expose truths the industry won't tell you. True masterpieces never needed premium pricing, just brilliant engineers solving impossible problems.